This is our second video recording, and we're going to be looking at this is our calculus class, and we're going to be looking at factoring today. So our objectives for this particular video lesson is going to be, we're going to look at factoring with the GCF. That's the greatest common factor. And then we're also going to be factoring polynomials in general. Okay, and so that's basically what we're going to work on over here. Okay, so we have basically, just as a couple of examples here, let's call this one example 1. Let's call this one over here example number 2. Okay, so if you can, we'll see if you can go ahead and factor this one over here. This is one good example of a polynomial factoring with the GCF. And here is one more. Okay, so go ahead and try these out over here. Okay. So one of the things that we're going to be looking at is we're going to look at the final result of this one here, right? And so if you factored this one out, so hopefully you notice that they have a 2 and that they have an x and they also have a y in common. Okay, and what's remaining is we're going to have basically x minus 2y squared here, and this one here we can factor out 4x, and this one is just going to be basically x plus 1, the quantity squared here. Okay, so see if you get that one. Okay. And so how do we do these in general, right? So first we have to understand what the word factoring means, right? Well, factoring means to factor, right? But what does that mean? Like what does factoring actually mean? Like when I say the word factor. And so what do we have to do is we have to go back and we're going to do an aside over here, and we're going to recall what factoring is. Okay, so what actually is factoring? And so basically factoring is to break down a number or a term to multiplication. Okay, and so what does that exactly mean for us? So as an example here, if I said factor 6, right, what would you say? So the answer would be, well, 6 is what? That is 2 times 3. Okay, so notice this here is a factorization of 6. What else is a factorization of 6? That's 6 times 1, right? Numbers can be, in this case over here, I've factored this number in 2 distinct ways, right? So one of the key things is one of these factorizations are to prime factors, the other one is not. See, 6 is 2 times 3 is a prime factorization, and 6 is 6 times 1 is not, because 6 is not prime. We're going to do the same thing over here. Perhaps it's a little bit more complicated with polynomials, right? So how do we do this? What do we do? Well, when we're factoring polynomials, right, we have to find the GCF, right? So we want to factor this polynomial here. Okay, and how do we do this in general? What do we do? Step 1. Let's do this in steps. First, find the GCF. Okay, what does the GCF stand for? The GCF stands for, that is the greatest common factor. Okay, that's what the GCF is. So how do we find this greatest common factor over here? Well, there's a few different ways of doing it. The easiest thing to do is to essentially break down each term here and see what they have in common, right? And so what we do is we write here, notice here, 2x squared y, that is 2 times x times y, 4xy cubed, this is 2 times 2 times x times y. If you notice, I've broken them all to their prime components. We circle their common factors. 2 is common, x is common, and y is common. And so that tells us what the GCF is. The GCF is 2xy. Okay? The GCF is 2xy. So therefore, when we want to factor 2x squared y minus 4xy cubed, what do we get? We get over here, the GCF goes on the outside. So this thing, you always put the GCF on the outside, and then you write what's left over in over here. Okay, so what's the GCF? The GCF was 2xy. Okay, and what's left on the inside here? Well, you just look over here at your two numbers. In the first one, what's left? Just an x. So we put an x. And then next, what's left in the second one? I have the number 2, so that goes here. What else? I have the variable y and y, and that gives me y squared. And then we have to put the operator between them, and of course that was a minus. And so here we have the final answer, which is 2xy times the quantity x minus 2y squared here. So this is a factorization. Okay? Let's practice one more. So what we're going to try and factor now, we're going to do another example here. Okay? Let's go ahead and try factoring the following equation here. Let's just say we have 24x squared minus 6x over here. And in this particular case, what do we want to factor? Well, again, you want to take out what they have in common, right? And so, what do these have in common over here? Well, and again, we want to write out each of the factors of the terms, right? So 24x squared, that is, 24 is going to be 2 times 2 times 2 times 3. X squared is x times x. Right, so all I did was I broke down 24 till its prime components. Do the same thing with 6x. 6 is 2 times 3, and I have 1x here. What do they have in common? They have 1, 2, they have 1x, and 1, 3. So what is the GCF? It is 2 times 3 times x, which of course is 6x here. Okay. So therefore, the factorization of this particular polynomial becomes here, the GCF goes on the outside times what's left on the inside, which is just look at what was not circled in each of the terms. I have 2, 2, and x, so that's 2 times 2 times x. And what's left over here? Now notice, here you might think, oh, there's nothing left, so it's 0, right? Well, no, I mean, it's not. Everything is gone, but secretly here, what is remaining is the number 1. So then, we put over here, if everything is gone, a 1 remains, okay? And the operator, which is minus, so that goes here, minus. And then if you notice, this is correct, but incorrect. Why? It's not simplified. So see this thing over here, this term, this is not simplified. Okay, that is not simplified here. Okay, so what do we do to simplify this one? We get 6x times, this is 4x minus 1. And this is our final answer here. Okay? Lastly, or the last example that we're going to look at over here, which was the other one, that was example 2. Okay, when we started off with, it was 4x cubed plus 8x squared plus 4x. Okay, and in this particular case here, you're like, well, what do they have in common? Well, let's see. Some of you automatically notice it's going to be 4x as a GCF. But in case you don't, right, we can write it out. 4x cubed, that's 2 times 2 times 3x's. 8x squared is 2, 2, and 2, x. 4x is 2 times 2 times x. And of course, you could see they all have an x. They all have 1, 2, 2 2's. So the GCF is 2 2's and 1x, which of course is 4x. So therefore, 4x cubed plus 8x squared plus 4x is 4x times, well, what's left over now? We have to check. So what's left over here? Well, in the first term, it's just x times x. That's x squared. Okay. In the second term, it is just 2x. I'm looking over here because that's 8x squared. Looking over here, it's 2x. And then in the last one, everything's gone. That means it's times 1. Don't forget your 1. And all of the operators are plus, so we put plus. And you might think we are done, right? And so it is true, this is factored. So let me clarify here. This is factored. It is true, it is absolutely factored, but not completely. It's not completely factored, okay? Why is that significant? What does that mean exactly? Well, that means that secretly there are other polynomials that we can kind of break it down to, okay? So what does this mean by this not factored completely nonsense, right? So for example, notice, if I have the number here, 24, 24 is 3 times 8, right? I have factored 24, but it's not completely factored. But not completely. Why? Because the number 8 can be factored more, right? So notice 24 is 3 and 8 is 2 times 2 times 2. Now here, this is a complete factorization. Okay, so really, when I brought up the original problems, okay, this is when we're talking about factoring, we're actually talking about factoring completely. Okay, so that should have been clarified. All right, so where were we last time? Last time we concluded that x cubed plus 8x squared plus 4x is 4x times the quantity x squared plus 2x plus 1. Okay. And so what do we do now? I have my two factors, and we notice, and hopefully maybe we do, maybe we don't, this also can be factored. Okay, how can this be factored? So this becomes over here 4x times x plus 1 times x plus 1. Okay, so therefore 4x times x squared plus 2x plus 1 is actually 4x times x plus 1, the quantity squared, right? Because there's two of them, and we get the square. Now, if you're unsure about how I went from here to here, we'll see that in the next video. Okay.